And now if you can solve another problem based on the same concept, you can see at your screen that we have a kind of same problem. What charge delta Q will flow through the source of EMF E in the circuit shown in the figure when moving key from point 1 to point 2? On that one, position 1 to position 2. So I would like to define the left capacitor with capacitance C with index 1 and the right capacitor with index 2 and this one with 0. And if the key is in the position 1, as we can see here at our screen, then the total capacitance of the capacitance system we can find. These two are in parallel and this with this in series. We can simplify the equivalent capacitance this time, and it will be C plus C0 divided by twice C plus C0. I know you can find it. And now we can find the charges on the capacitors, individual capacitors. The charge on capacitor C is Q1, and Q1 you can find it. That will be EC square by 2C plus C0, and charge on capacitor C0 as Q0, and that will be EC C0 divided by 2C plus C0, and charge on capacitor C on right, that is indexed as 2. So the charge on this can be written as Q2 ECC plus C0 divided by 2C plus C0. And after moving the key to position 2, the capacitance of the capacitor system will not change. It will remain same, though total equivalent capacitance. But charges on the capacitors will change and they will be equal to Q1 dash. You will solve of your own, and you can see that Q1 dash becomes ECC plus C0 divided by 2C plus C0, and Q0 dash, it remains same. Q0 dash is basically equal to Q0, that is ECC0 divided by 2C plus C0, and Q2 dash has changed to EC square by 2C plus C0. Total capacitance remains same. But if you can see, the charges on this left capacitor, this C1, has changed from Q1 dash minus Q2. Q1 dash minus Q2. So change on capacitor C on the left is delta Q1, and this is Q1 dash minus Q1. And the change in charges in capacitor C on the right, that is index 2, is delta Q2, and delta Q2 is minus delta Q1, because the changes has taken places like this, and both have magnitude equal to EC C0 divided by twice C of C, twice C plus C0. So you can say that this is the only charge that will pass through the EMF source, and whenever you recognize this because this is either this or this, both have same magnitude, so this charge will pass through the EMF source, only this charge, and problem is solved. Thank you very much for watching.